So today we will see a problem from Unit 3. So the problem is a buck regulator has an input voltage of Vs equal to 12 volt. The required average output voltage is Va equal to 5 volt at resistance 500 ohms, and the peak to peak output ripple voltage is 20 millivolt. The switching frequency is 25 kHz. If the peak-to-peak ripple current of the inductor is limited to 0.8 ampere, determine the following. So we have to find alpha, the filter inductance L, the filter capacitance C, and the critical value of L and C. So first we will write the given data. So given data, input is equal to 12 volt. So Vs or VDC you can mention. So it's a chopper, right? So chopper circuit. So chopper is converts from DC to DC only, right? So either Vs or VDC you can mention. Supply voltage Vs. The average required. So Va notation is already given there. So Va equal to 5 volt. Then R value is given as 500 ohms. Peak to peak output ripple voltage is 20 millivolt. So peak to peak ripple voltage. So the notation will be del V naught. So del V naught will be 20 millivolt. So milli. So I'm writing as into 10 power minus 3 volt. Switching frequency is 25 kilohertz. So F 25 into 10 power 3 hertz. If the peak to peak ripple current of the inductor is limited to 0.8 ampere, so peak to peak ripple current, so del I equal to 0.8 ampere. So what we have to find out? First we'll find out alpha. So what is the formula we know? So it is a buck regulator. So buck regulator, what is the formula? We know with respect to a duty cycle will be V naught equal to alpha Vs. Right. So V naught output voltage, average output voltage, it is already mentioned. Vs is also given. So alpha equal to V naught by Vs. So V naught output voltage is equal to 5. So 5 divided by 12. So value you will be getting is 0.4167. Next. So next what we have to find is the filter inductance L. So with respect to this L, what all formulas we know? So with respect to the given data, so we know a formula. So here delta I, so ripple peak to peak ripple current of the inductor. So del I formula what we know is V naught T divided by L into 1 minus alpha. So del I is already given as 0.8. Yes, V naught is the average output voltage of 5 volt. So T. So here time period. So we can so frequency is given, right? So F is nothing but 1 by T, right? So with that also we can substitute. Alpha also we have found out. So from this we can find out what is L value. So L is equal to, so it goes there. So V naught T into 1 minus alpha divided by delta I. So in order to substitute F value, so I will write Instead of this T there, I will write here F. So F is equal to 1 by T. So T is equal to 1 by F, right? So instead of T, I have substituted 1 by F. Okay, so substituting the values, we will be getting, so V naught will be, V naught, what is the value of V naught? 5. So 5 divided by 0.8 into 25,000, right? So here into 1 minus 0.4167. So L value will be 145.8 microhenry. So alpha will be 0.4167. So next what we have to find out? Filter capacitance. C we have to find out. So what is the formula we know? So similarly to this filter inductance L, we know that delta V naught is equal to delta I T divided by 8C. So we know delta V naught, we know, right? So delta I also we know. For T we can substitute 1 by F, and from this we can find out C. So C will be delta I divided by 8. For T I am substituting 1 by F, then this comes here. So delta V naught. So substituting all these values, you will get 200 microfarad. Next, final one, critical value of L and C. So critical value of L and C. LC is equal to 1 minus alpha divided by 2F into R. So substituting, so alpha we know 0.4167, R value will be 500 ohms, and F value we already know. So substituting all these values, we will be getting F 5.83 millihenry. Final one, critical value of capacitance. So that will be 1 minus alpha by 16 LF square. So substituting all these values is equal to 0.4 microfarad. So critical value of capacitance will be 0.4 microfarad.